difficulty doing either of those things, we do have capabilities to do that on our end. So we will be going around and turning off microphones and videos if you're having difficulties with that. This recording, once it is posted, will be shared to University of Illinois Extension's YouTube page, and that should be up within 2 to 4 weeks once it's processed and closed captioned. And I will go ahead and share the link to that YouTube page in the chat box if you want to save that for reference for this webinar or want to check out some of the other webinars that we've had in our series. If you do have a question at any time during the webinar today, please feel free to type it into the chat box, and we will hold them and address them all at the end if we have time. Jay also has an evaluation that we ask you to fill out. You can see the link on the screen right now. We'll share that in the chat box as well in case you do have to leave early, and then again, we'll share it at the end of the presentation. And Jay, I think that's all that we have, so I'll turn it over to you to get started. Thank you, everyone.
Thank you, Erin. And yes, I did get the recording started. Glad to have everyone here on this nice, sunny, warm afternoon. Good time to talk about ponds. So my role today, or the topic was planning a multi-purpose pond. I know there's some discussion about it, and I saw some questions in the chat box about it as to what we might be covering today and what we might not be. But I want to start by giving you a little bit of what the kind of thinking about trying to cover anyway. I'm going to start with the discussion and hope that I get you started in thinking about how to design and starting the construction process of a pond. In other words, some place for you to start from the ground up and move forward with one if that's where you're at. Key piece of this is being able to ask the right questions before you start the construction and working with contractors or whoever you might be working with going forward. And getting you to think about how to design it, what you want it to be, those kinds of things. Really looking at some things that maybe make the design a little easier for maintenance, and basically what we really want to have is years of joy out of it, right? And the other thing that really stuck out to me as I was kind of preparing this and has for some time is basically looking at trying to design so we prevent any small dam failures. We're all aware of the large rainfall that occurred in the Michigan area and the two lakes that suffered catastrophic failures. We don't want to have our small ponds and our farm ponds and those kind of ponds having those kind of catastrophic failures if we can prevent it. So that's a little bit of where I'm coming at with some of this and thinking about how do we design that, how do we manage it so that doesn't become a problem. A couple of things I wanted to kind of lay out so that everybody knows where we're at and what we are and aren't going to cover. We control fish stocking rates, what type of fish, some of the predator management, and backyard ponds are a little bit beyond the scope of what I was really looking at when I started putting this presentation together. I did see some questions from a few people related to those topics. If you look at the backyard ponds, a lot of what I want to talk about still applies to those. It's a matter of scaling it down. The fish stocking, weed control, that's actually a whole entire presentation in itself, and I actually have already asked some of my colleagues or suggested some of my colleagues that maybe that's a topic that maybe one of them might want to try to take on and cover in a future webinar. So with that, I'm going to kind of move into what are we thinking about here. So kind of the topics that I want to talk a little bit about is get you to think about what the purpose is, why are you building the pond, what are you expecting out of it, what do you need from it, those kinds of things. A little bit about sizing, and particularly in the consideration pieces of it. Sizing and site selection kind of go together in looking at where to put it. Is your idea of what your pond realistic for the site you've got? And I come at that from two perspectives. I've been around ponds that were uh, designed too small for the watershed that they had. And the flip side of it is expectations to have this great big, really nice pond and not enough watershed to actually feed it and ever fill it up correctly to start with. So I want to make sure that we don't get into either one of those positions with with your construction, your plans. I'm going to talk a little bit about some of the construction and a little bit more of some of the things that are maybe often forgotten, and a little bit about the basics of construction, so you have some idea of some of the things that you should expect to be put into it if you're having someone else design it and build it. The last piece is in protecting it. Again, going back to not having that catastrophic failure in the end, things we want to be sure we try to prevent. So with that, I'll start kind of down through this list. Some of the purposes we might think about are, a lot of people, recreation, place to go swimming. Had friends, what they wanted, place picnicking, around the edge of it. A lot of people want a place that they can do a little bit of fishing, teach the next generation how to fish, the joys of just taking it easy. Others want to see wildlife. Want to provide something for the wildlife and an attraction for wildlife and a chance to view them. Livestock, where I really got into a lot of this was with livestock facilities, livestock watering sources. And that's quite often where we're looking at them, that or irrigation. Place to get some water for a crop if we need to, especially some specialty crops and small truck garden type setups. I've seen ponds constructed for that reason. Fire protection is maybe something we don't always think about. And yes, it's a source of water. And it's one of those pieces I want to remind everybody that there's an opportunity for out there. And a lot of rural fire departments are looking for that additional resource. And there's some things we can do to make it more of a resource to them in the event of an emergency. I want to kind of get you to think a little bit about that. And stormwater retention. Obviously, that's stormwater retention or erosion control can be another major reason for building a pond. But the real key is to think about not just one of these reasons, but let's look at what are those different reasons we can put together and create what we would refer to as a multi-purpose pond. You know, a pond can do a lot of these different things. Maybe we designed it for livestock, or we designed it for water retention, erosion prevention, but it should design correctly. The recreation, the wildlife should be pretty easy to get in there and be part of it as well. Just a matter of thinking about it ahead. So I'll start with this pond. And I encourage you to take a minute to take a look at this pond and think about what might be the purposes that the individual who built this pond or the family that built this pond, what they may be looking at using this pond for. And I put together a list there. The obvious one, fishing. You can see obviously enough area in there. There's a duck nesting area in it. You see the nest piece there and close in the picture there. What's not real obvious, you see the beach on the far end, kind of a sand area for younger people to play in, children to play in. What you don't see is right off to the left, there is behind the trees there's a picnic table and a picnic area. It was basically built for the family to get together, multiple generations to come down, fishing, dinner, those kinds of things, getting together over the weekend. It's also a water retention area and erosion control facility. There's a pretty good drain coming off that field below, and what you can't see is down below. It gets pretty steep. But all of those reasons are what we see in the picture and what it's being used for now. The facility was actually originally built for erosion control and livestock water. And a lot of people think, oh, if you got livestock water, it can't be used for anything else. In this case, they designed it in such a way they're actually drawing water out of it through a pipe in a controlled manner going down to the livestock. And so it's meeting all of those goals in one step. And that's the kind of thought process I hope that I'll come instill in you as we go through this. So a few things about sizing. Now, I often get asked that question in an older pond, or I'm building one, and the classic that I've heard from some of the NRCS folks is getting that phone call of, hey, I need a little bit of information about sizing for a pond. And we ask the question, okay, when do you need it and where's it at? The bulldozer will be out here after this afternoon to start on it. That's a little late to think about the planning part. So really try to think through this. So part of this is we're going to do for fish in the northern part of Illinois where I'm at, up in the northwest corner, minimum of 10 feet deep. We need a fairly decent area down at that depth. That creates enough depth in there for both sediment getting in there to extend the pond life itself. Also cold protection for the fish. In other words, it keeps an area where there's going to be enough oxygen and the water's not going to freeze up for the fish to overwinter. What we often see is in the spring, a fish kill, I've had some kind of fish kill, something's wrong. Well, it froze all the way to the bottom, and that's the problem. Or they froze down deep enough and they ran out of oxygen in the limited area they had. Majority of the pond needs to be somewhere over about 5 feet deep in average. And especially if you look around most of the edges of it, that sharper drop off will really help us with weed control. If you come in and have a very gentle slope coming into it, you've got a lot of water that's in that 0 to 3 foot deep in a pretty good area, you're going to have a lot of weed problems right along the edge. But also by having this varying 5 foot zones and some of the other deeper zones, you're going to have more temperature zones for your fish. And as the year progresses, like this year, a little bit colder, they're going to be towards the top. Get down in the middle of the summer, a good number of them are going to be going down a little bit deeper, which is just a little bit cooler. One of the other big pieces of this when we start talking about the size of it is preferable size to start from is somewhere around 1/4 of an acre or larger. And that's from a maintenance standpoint, from a cost standpoint, those kinds of things is an important piece to look at. So falls into the sizing, but the site selection piece of it here. And this comes into that thinking about the right location to put a pond in. And there's a few things maybe I haven't put in the list here, but let's start with the drainage area or the watershed ratio. Basically needs to be somewhere in that 10 to 1, in other words, 10 acres to 1 acre or 20 to 1 range for most ponds. Now, one caveat to that is if you happen to have another water source that's pretty significant, like a spring or a small creek with a fairly limited watershed, but is spring fed or whatever it might be that provides that source, then your area can be a little bit on the smaller side and make it work. But you've got to be sized for that water source coming in. If we're talking about a 1/4 acre pond, that means that somewhere between 2.5 acres and 5 acres is that ideal watershed size. So as we look at that first picture, you've got that area up above the field there, and that was about close to a 1/2 acre pond, and they had about 8 or 9 acres draining into it. So there's kind of your sizing that you're looking at. Now, some other things to think about. Do we have a place to put in there where we can do some nutrient and sediment filtering? Is there a strip in there where we can run what we call a vegetative filter? Run the flow through a grass and plant area that's fairly dense, that will and fairly level right to left if you're looking down it, up or down it. And not a real steep slope. So it'll take us time to run through that area, and that vegetative filter will pull out a lot of the sediment. We'll let the sediment settle out, and the vegetation will pull up a lot of the nutrients out of the water. So give you cleaner water going into the pond. General rule is we're looking at about 100 foot of length to get a good filtration through it. There's some design things in there, but that gives you a good idea, rough number to work from. The other option is to put in a settling basin, and that's basically just a pre-pond. It's an area in there where it collects the water in it, but it's designed to drain all the way down, and it holds it for a period of time. And primary thing is settling out the sediment, but in doing that, we'll pull out part of the nutrients, especially the phosphorus, out of the water. So that's where a settling basin is kind of nice if you've got a lot of flow coming into it, or you're coming off of a lot of crop ground, because it gives you a chance to settle that soil out that's been displaced, keeps the pond from being quite so muddy. It also is an area that when it dries out in the middle of the summer, you can bring equipment in and actually dig that back out and reset it occasionally and not have to actually redo the whole pond. So other pieces of it to think about. If you want wildlife, if you're designing this for wildlife and being able to enjoy seeing deer and other animals come up to it, you need to recognize that there and think about where's your timber lanes or your shrub lanes, places where the animals can safely, comfortably get fairly close to the pond, or feel like they can go out to the pond and get a drink and then get back into cover if they need to. One of the things that I've seen some an individual come in, I want to build a pond for wildlife, and they go in and clear everything where the pond is and several feet back, 100 foot back from it, create this big wide open, looks like a football field around it, and then they wonder why they don't see a lot of wildlife in it. So while you really need to do a lot of, we'll talk a little bit in construction about clearing the stuff in the pond, in the pond construction area, the stuff right around it is as natural as you can leave it is a better way to do that. Again, sight lines, being able to see those animals can be important, because you got the timber and shrubs up there to a point where it's going to invite the animals to come out in an area where you can't see it. Well, have you really achieved what you wanted? Sight lines also important from safety. If you got children around, others that may be swimming in it, a place where the adults can see, stay in the shade, maybe stay close to the house, and still be able to see and make sure that everybody is safe is important. So construction of the dam, let's talk about some of the basics, some of the obvious things. And these are things that your design individual will know. And then basically your equipment contractors, most of the guys the folks who build ponds on a regular basis, they know a lot of this stuff pretty well instinctively. They do it all the time, and that's the minimum width. You need a minimum width of that dam, and especially a minimum width of the top of it, to ensure that for the depth you've got, it's a stable structure. It's important the slopes you're looking at on both going up from the pond side up to the dam, top of the dam, and the slope going away from it are both fairly important in that structural integrity. Making sure it's solid and impermeable core. We all kind of recognize that one. Make sure that core is something that really isn't really there and isn't going to leak is important from that structural standpoint. Some of the less obvious things that don't always get put into the design, especially on some of the smaller ponds, you just call somebody out to quickly dig a pond, and especially you see this one in erosion control ponds, is thinking about how much flow do we have in there, and do we have what we call a freeboard depth? In other words, a depth where it's going to fill up to, and then our spillway or our pipe is going to keep it from overflowing and filling up beyond that. Because the last thing we want to do is water to go over the top of the dam, because that's what really leads to catastrophic failure of a structure, of a dam structure, whether it's a pond or a lake or any other. We see it with levees. Anytime it overtops your structural integrity, you've lost control of it at that point. Given that, what's your overflow? We know that we're going to have rainfall events that are going to be a little bit more than what the water we can handle in there is going to be, how are we going to drain that water out of there and keep it under a normal rainfall event at an ideal height. And then an emergency spillway. Those events when we have those really heavy rains, it was full to start with, that giving it a place, the water a place to go so it doesn't go up and over the top of the dam. So with that, let's talk a little bit about the dam itself. Minimum width, we'd like to have for a 10 foot of water held behind the dam. Basically need about a 10-foot width at the top of the dam. It needs to be, the structural key component of it needs to be at least 10 foot wide. And that's for one that's, up to about 20 foot deep. You need to increase that width as the depth of the water behind it increases. And as you get much over 20 foot, that's really when you need to have somebody engineer design this and really go through the numbers on it to make sure you've got all of the pieces of it correctly set. That front slope, somewhere in that 3-to-1 ratio in there is what we're looking at, and that's the slope inside the pond. And what you get there is you're by having that flatter slope, you've got more of the water pressure pushing down on the pond dam and on that side of it and helping to seal it rather than trying to push it outward. The back slope is not quite as important. The piece there is, how are you going to maintain it? Sure, a 2-to-1 saves you a little bit on the construction cost of it, but at that point, how are you going to mow it? Are you going to use a weed eater type string trimmer across it? Are you going to actually run a mower across it, or a tractor mower across it on that, at least on a yearly basis for maintenance? Some other pieces to expect in there, and this is something that if you've got a contractor that's built one before will obviously know it right off the bat, but any of the native soils that you're building the dam into, you need to go in and do what we call scarified. That is, come in and tear it up a little bit so that whenever you add the additional soil onto it, it bonds together. So you don't end up with the soil laying there that was there before, and especially the worst condition is to actually not come in and take the topsoil off at all and just start building on top of that. Now you've got this layer and there actually isn't any connection between them, and the potential for that dam to actually slide off of it or water to seep between them is really in history, we know that's a problem because we've seen multiple dams that have failed in that mode. So the other part of it is to come in and key it or trench the core of it. So the core piece of the dam, actually dig that down to an impervial layer and then start building the dam up in roughly 9-inch lifts and pack it as you go up. You don't just stack everything up and then run something across it and hope you get it packed down. But you actually have to plan that as you go up. Then comes the spillway piece of it that needs to be put in there initially. And this, another classic that I've seen is, oh, we'll build the dam and then put the spillway pipe through it. And that's not something you want to do either. You want to put that pipe in and know where it's going in to start with. So you want to install it to have that design freeboard. 3 foot's a minimum. Maybe you want to design it because you've got a high flow on it. Maybe it's a 5 foot, and know that during the spring it may be closer to filling up and having a couple foot above the standard drain pipe, and we'll, over the course of the summer we'll drain back down to it. But you don't want to get anywhere closer than about 3 foot to the top of the dam at any point in time. Size it for the outflow, match it for the natural flows that are coming in. If you've got a spring or if you've got a stream coming in, the flow going out needs to match that stream coming in as a minimum. And then you need to be able to put in a little bit of additional flow in there to carry the rainfall events in the watershed you've got. Again, need to refer back to those drainage area calculations. How much water do we have coming in there? How deep is it going to get? How many acre feet of water do we have coming in? If it's already full, how are we going to deal with that? The auxiliary spillway needs to be designed to provide an outlet during the large offense. Its purpose is to prevent those catastrophic failures of the dam. Can be a separate pipe. It can be open area and part of the structure. I'm actually going to show a couple of options where a couple of them that I have better pictures of are actually concrete structures, but it's the spillway and the auxiliary spillway are designed in one piece. But let's start with the pipe spillway. If you're looking at a pipe version or a box version of it, it needs to be designed and put through during construction. Install it or other structures, to provide that freeboard. Key piece here, put those anti-seep collars in on that pipe as it goes through the dam. And they need to be down in the dam area and part of that construction. This is where the pipe driven through it afterwards becomes a problem, because you've got water flowing through the pipe, but if the soil gets a little bit dry and opens up around it, as you get water seeping in from the top side, it can eventually work its way all the way through the dam along the outside of the pipe. And then you get water flowing around the outside of it, and that's what just takes the pipe out, and then the dam failure. It goes out with, it basically sucks through that same hole and collapses from that point. So really important piece of that is those seep collars and the placement of them. Another way to do a spillway is the open channel. Here's an example of one. Kind of a neat setup. This happens to be one that was designed for recreation primarily. Unique in that it is a fairly low watershed ratio, but they had a really nice spring on the property that was already creating a small natural pond, and they just built upon that feature of it. So if you notice, designed where they can walk over it. You see in the upper picture, or actually in the two corner pictures, that's kind of the natural flow of the spring through it. So you got just a little bit of water flowing through it all the time. And you see the open area there for any rainfall events, and that's your emergency spillway where it drains on through there. One flaw or fault in this one that I see with it is, you notice the barren soil on either side of that spillway. Should it, and it is actually sunk in just a little bit, should it get up close to the top of that, or actually over top that spillway just a little bit, really puts that dam in danger. One of the pieces to this, though, is while you see the tracks across it, it's also, they had just done some repair work on it and had been reseeded and the grass hadn't taken back off and reestablished in that area. So under normal circumstances, it wouldn't be quite that much barren ground around it. Here's another structure. It's a little bit larger structure, same general concept. This one is a watershed area flowing into it, a little bit of a natural stream flowing into it. Unique from a design standpoint in that if you notice the trees and the brush off to behind the open area there and to the right hand side, that's actually a stream that the water from this would naturally have flowed into. So rather than intercepting that stream from a size standpoint, they actually built it off to the side of it and actually dammed up along the edge of the stream to create the pond. And rather than trying to catch that bigger stream that would have created too big of a lake for them, would have created a lake instead of a pond for them to manage. So in this case, they designed it to catch a specific amount of water and then designed the rest of it around it. Now, another unique thing about this one is, as I say, it's the primary spillway and also the emergency spillway, and a little bit of thought into keeping the fish in there. Notice the screens in there. Those are in there that as it fills up, they filter and keep the fish and some of the debris from plugging up the spillway as well caught there in front of it. Here's a little bit better shot of the same setup. You see the walkover bridge, drive over bridge for the lawnmowers and the light equipment. But on the right-hand side, you see where the concrete weir, basically the top of the dam where the spillway where it's catching water and flowing it over is at, screen setting there, and you've got this large volume that's capable of handling all the water. Should it get a large rainfall event coming in, a large slug of water coming towards it, it's got a place to go. So let's talk a little bit about emergency spillways if we're not going to put them in as part of a concrete structure such as that. One of the things in the other design is to do a excavated earthen spillway. And the reason we say excavated is that it's not going over the dam. You actually go into some of the native soil off to the side, one side or the other of the dam, and dig in and create a pathway around. That way you have more a more secure, more solid surface, and you actually pull it through a longer area there to do the construction, so you can control the flow rate and the erosion potential for the water that overflows it. It has to be a fairly long, fairly wide area. It needs to be a wide, long, level portion of it. You want to get that flow. You don't want it to come over the top and start spilling. You want it to come across it fairly level so that it doesn't have all that energy in it to tear the dam up, tear up the spillway. Should be below the berm height, in other words, the ultimate height of the dam. And you need to do some things to protect it from erosion. Basically, can be grassed in. Some of them have got some rocks in them. There are different ways they've set some of these up. There's even one of these that I know of on a large reservoir in the Peoria area that has a concrete surface in the middle of that to control how the water spills over. On smaller ponds, you have the option of doing a secondary spillway, a secondary pipe as the spillway. A larger pipe up a little bit higher that's designed to intercept and catch that water and take it on out. Small one that drains out the standard water coming in, larger one up a little bit higher up that takes the water on out. Or the concrete structures like I've shown you already. Not something I expect you to absorb all of, but for example, here is one of the reasons you might want to contact NRCS to get some help from them. These are their standard drawings that they start from. And key things I wanted to point out here is if you look into the sketch on the right, you see the plan elevation. That's the top of the dam, the pipe inlet for your normal spillway. The emergency spillway, you see that it's a notched area. It's a given width by a given length across it, so that it actually gets and it has a chance to get that water to flow smoothly across, rather than being a turbulent flow going across it. And then there's a little bit more of a cross-sectional detail in the other picture there of how you would go about designing this, and there's actually a whole page of details and how you get all the numbers associated with that. It's kind of a cookbook system to put that together if you want it, if you try and do that. Some other considerations to think about. One of the things I think the biggest piece of it is, besides thinking about your site selection and where you want it, what are you trying to get out of it, is once you start, is doing good preparation here. You need to clear the trees and brush from near where the foundation area for the dam is going to be, excavate where the spillway is going to, and where the excavated spillway is going to be, remove the topsoil. You want to get down to a layer that will pack down and be impermeable, and most of your topsoil will not do that. Need a higher clay content in it. But minimize clearing the perimeter to maintain some natural character, especially if you're looking at one that you want a nice visual piece of it. And think about whether it's a natural one or a totally man-made one, to create it as some irregular shapes rather than being being square or a perfect circle or the dam in a loop coming out behind it. Try to give it some nooks and crannies and some corners. Gives it more character, makes it look more natural, also gives fish a little bit better place to hide, and will help from your if you're looking trying to keep a variety of fish in there, has a great benefit for that as well. As far as sealing it, I know there was some questions about sealing the pond. You know, the very first thing is down in the bottom of it, take the brush out of it. I know on some of the larger lakes and stuff like that, you know, that we don't always take those out, but on a pond we really need to go in and take those out, because when we're talking about scale, even on the large lakes that they will, the Corps of Engineer lakes, they'll go in and remove the trees from an area coming away from the dam, going back a certain distance, to ensure that they don't have tree roots and stuff like that that eventually will cause deterioration or cause some problems with the dam and potential pathways for water to get underneath their area that they've got compacted. You know, some options we go there. You can compact the existing soil, install clay blankets. In other words, lay some clay in there. You need about 20% clay material to get it to really seal up. Desired depth for that is about 12 inches. And then you need to go about 2 inches more for every additional 10 foot that you go up in height. So if you've got a 20-foot deep one, you need about 14 inches of compacted soil down there to make sure you get it to seal up and you don't have water being pushed down and potential of it breaching your dam from underneath. Another option is to add bentonite to it, which is a very high expansion clay. And there are tables on recommendations of how much of that you use, and a little bit is based on depth of the water and characteristics of the parent material. So that's why I didn't give you a number with it. So some of the other things we might do with a pond. We talked about accessories. A dry hydrant is something you could put in there. Again, talking about it having access for local fire departments to draw a little bit of that water, draw down a little water to fire protection, to control the fire, whether it be a house fire, or we particularly see this being of interest in some of the brush fires that we have. Being able to pull water, because they're often out way away from any other facilities and in need of large amounts of water. Trick with that is essentially you build that one in, can build it through the dam, or it can be put into the edge of it. And a dry hydrant means that it's got a pickup point that is protected and below the water surface out there, comes out to the edge of it, and a riser comes up, has a specific connection on it. The fire department can come up, open the cap on it, connect to it, draw water through it with their pump equipment, vacuum, and use that to pump either into the truck and fill the truck, or they put a pump truck up there and they can pump straight to the fire from it. Other things we've done, especially when we're looking at for livestock use, is what we call a dry well, and that's where you put essentially what looks like a well or a hole off to the side of it with pipe or gravel into it, and down in that you can drop a pump down in there and pump water out of it, whether it be for irrigation, for livestock water, those types of applications. And then livestock water, the picture here shows a design for doing livestock water downstream from a dam. The picture that we started out with from the family had built, this is how they had done theirs. There was close to where the picture was taken from, there was a valve where they could shut it on and off, which is one of the key pieces, very important piece to put in there, because some of the stuff downstream from that does have a tendency to fail every once in a while and need to be replaced, hydrants and that kind of stuff. So having that valve right there at the dam is pretty important. But just as you would the pipe for your spillway needs to be put in with the anti-seep collars and through the core of it, so that you don't open up a pathway for water to get through and cause problems later. Now, there were some questions about protection, and here's a few things to think about is once you get started with it, and once you get the pond finished, planting some plants that will quickly establish, such as grasses, some of your native species in those exposed areas, in those open areas, is definitely something you want to do pretty quick. Couple of things about that. One, it keeps your erosion, your soil, any soil loss into the pond, because you've dug this out, you don't want the soil going right back into it. The other thing is it gets it established so that you've got that natural area that you wanted, whether it be an area for a family to play on or for wildlife, you're headed back that direction. A lot of times we'll think about putting some riprap on a base of gravel. In this case, the individual on the right, they use some pretty heavy rocks along, and this would be along the far east end of this pond. What they knew is a lot of wind, and this particular area was kind of open area to the south and to the west and southwest. Natural area, a lot of wind action, a lot of wave action coming towards this corner, and they didn't want it to erode. They actually had right in that area, they had kind of a family picnic area set up, and so put those large rocks in there to absorb that wave energy. Along that same pond over on the far side of that, so this would be the south side, the larger picture on the bottom, you're looking at the south side of that. So they put a few larger rocks in there, but more of just a moderate sized riprap in there, gravel base in there to absorb some of that energy. And also it's pretty steep, so it keeps it from eroding and sloughing off, limits how much plants will grow up in there, that kind of stuff. And good way to keep some of the plant material out of the pond. Kind of gives you an idea when we talk about a little bit steeper slopes along those edges. That's a good picture there, kind of depicts some of that, how this pond, they actually dug it with a pretty good drop into the water. It drops into about 5 feet pretty quickly. So you don't have 10 or 15 foot out into the pond that's not more than about 3 foot deep. It drops out pretty quickly. Other things to do to protect it, and we've already talked a little bit about this, is anything you can do to reduce the sediment and nutrient load coming in there definitely would be a piece to think about. Some things that I think about on that are looking at what's up above it. Again, looking at your settling basins and vegetative filter strip is a good way to do that. Also thinking about what crops you've got out there might be a place to work on it too. So I mean, there's a lot of things to do with that in protecting that. I'm not sure what to do. It varies a lot with what area you've got, what the pond is, what your watershed is. Kind of in summary to this, kind of bringing this back together, biggest piece of having this pond that you can enjoy for years into the future is start with some good planning and preparation. Think about what you want it to do, what's that main purpose you're thinking about with it, but what else could it be? This particular one we're looking at here was built for this purpose as a pond for them to fish in and to be around, but it also had, by selecting the location they did, it helped improve some water quality downstream from some crop acreage. It also controls an erosion problem that they already had. As the gentleman said, it took a little bit of land out of their crop production, but it's land that they might have lost if they hadn't done this. So again, tying those multiple purposes together. Look at that minimum of a 1/4 acre and a minimum of 10 foot deep and a fairly good portion of, or a decent portion of it at that 10-foot depth to ensure you've got good habitat for fish. Watershed ratio, somewhere in that 10-to-1 to 20-to-1 maximum. I would say the thing that concerns me the most in sites that I've seen is individuals really pushing that 20-to-1, not thinking about what the watershed really is, how much water is actually draining into this area, and they just want a little small pond in their acreage, and especially if they don't own all the acreage above where it's coming from, and not sitting down and thinking about how much water is really coming down through here. And there are ways to deal with that, similar to what the individual in this pond did, of going in and actually not capturing all that water, divert part of the water around it, and just capture enough to fill the pond and make it what you want it to be. Really think about that primary and emergency spillway design so that it meets that ratio, so you don't have to worry about, we got 2-inch rain on saturated soils in a pretty short period of time. Is my pond dam going to collapse? Am I going to lose the pond? Am I going to flood my neighbors out? Those kinds of things. With a little bit of preparation, we don't have to worry about those things. And I want to ask a couple of colleagues of mine, here's some resources. We'll provide you with these links in the chat, but also when we send out a reminder about the survey at the end, we'll send you the links, the actual hyperlinks to these resources. Really good resource to you. Local NRCS, Natural Resource Conservation Service. Their engineers have gone through the standards. Can say that I've worked with, and some of us have worked with NRCS engineers in developing some of those standards, but also those standards have been developed nationally through years of experience from a lot of different sources. So definitely a piece to look at. The engineers are a good resource. Your local NRCS soil cons are a good resource for that. The pond and planning design construction is another good handbook that's out there for a number of years. And as some of you may or may not know, I got started doing some of this stuff in Missouri. So my first run at this was actually many years ago. And the Missouri Pond Handbook just happens to have some very good of the graphics that I used in here. So I've got to give credit to them. So with that, the thing that I would ask is, here's the link to the survey. There's also the QR code that you can use on your smartphone to get to it very quickly. And I would turn it back to Aaron to see if we have any questions that I totally missed.
All right, thank you, Jay. Wonderful presentation. I have been posting links in the chat, and for some reason the hyperlinks are not working, so I do apologize. But if you are interested in following any of those links, you can just copy them and paste them. For some reason, the hyperlinks don't like me right now. But we do have some questions, Jay. So let me get those pulled up. So our first question is, what kind of credentials should you look for if you want to hire someone to install or help maintain a pond? Do you have any recommendations?
Not specifically. From a design standpoint, the folks, as I say, the engineers, the staff with NRCS have access to some pretty good resources. The people that they contract with and that do the technical service providers, the TSPs that work with them, they'll know which ones of them have been through some training to do some of this design work and that kind of stuff. They also would know who in the area has some good experience building ponds. And so I would almost say there's kind of two different things here. One, you need somebody who understands the engineering part of it to do the design work. You need somebody who's a very good equipment operator and experienced at building some of these and understanding how to take that design and make it real world. And those credentials are, to some extent, hard earned. So asking others who have or who've had ponds built, or asking for experience and references. If you're looking for somebody who to do it, ask them for references, just like you would anybody else. Is there a pond that, can I go talk to somebody else who you've built a pond for and possibly go look at that pond? That's some of the best ways to find those two pieces, unfortunately.
Okay, thank you. We had a question about, they just asked you to comment on trees around and on a dam. So I'm assuming, since you talked about clearing vegetation to build the dam, they're asking about if you would want trees to grow near or on the dam, or if you'd want to prevent that from happening.
You do not want, and that's something that I didn't cover on the maintenance side, you don't want trees, woody type brush, anything that's going to have a lot of large, deep reaching roots, because they will basically damage the dam. They'll hurt the integrity of the dam, both while they're growing, because they have the potential to spread things and push. If it gets in between a couple of rocks, some of those larger roots will actually move the rocks apart. And if the tree dies, then now you got this open pathway. As that root decays, shrinks back, you've got this open pathway now through there. So anything that causes a hole, burrowing, crawdads, any of your burrowing animals, and trees are something you want to keep away from the structure. Now, you saw the ones that were on at that initial pond that I was looking at, that I showed. There are trees close to it, but you do want to keep them, basically, you want to keep the canopy. Think about the roots being about the size of the canopy. You want to keep that canopy from being out over the dam, or even on the edge, at the edges of it. And you want to be a little bit further than what that canopy is going to be away on the ends of the dam, because you have a potential for creating some structural issues from there. Further back, you're okay with trees around a pond. One of the things about that mowing, not something I don't advocate and say that we need to go in and it needs to be like a golf course or a yard, but it is a good idea to come through and mow it roughly at least once a year. And what that does is it takes out a lot of that type of growth. If they have a tree growing into a dam, it probably needs to come out, but they may need a little technical assistance to figure out whether as it dies, it's going to cause some structural integrity issues or not.
Great. Would you also recommend the same distance, looking at the canopy line, for other trees around the pond, not just next to the dam?
Around the pond is not quite as critical.
Okay.
That is assuming that is native soil and you've got a little bit of slope coming up from it, because in those cases you're not opening up crevices area for water to go around the dam and go towards the lower end of it. Now, as you get closer and closer to the dam, there's a zone in there where you really want to kind of think about keeping them away from it. And I should say that varies a lot by the soil conditions, how the pond, the layout of the pond itself.
Right. Okay, great. We had a question about if all sides of the pond have to have a 5-foot drop, and if not, what percent would you suggest having that drop?
You don't have to have all of it. the more of it, and especially if you start from the dam working back towards where your water source coming in is at, the more of that you can keep in that somewhere close to a 5-foot drop, or getting it down to that 5 foot pretty quickly, the less of a weed problem you're going to have around it. Again, I'll go back to a couple of those ponds where they had kind of a beach area at the back end of it, the further end of it, in a sand area. That's not a problem, and at that point, you've got an area that maybe goes down a little bit. It's kind of the swimming area, and is a little more gentle slope into that. The thing you have to do is that area is probably one you really want to kind of focus on any weed management, weed control, so it doesn't become an issue long term. So the real answer to that question is how much of it can be left out depends on how much weed management, how active you want to be in your weed management.
Okay, thank you for that recommendation. Someone asked what, if you have a recommendation for a good grass to plant on exposed areas right around the pond.
Not specifically. I would probably plant something besides a grass, a yard lawn, a lawn species of grass. Something that's got a little more structure to it. It tends to be a little bit higher, a little more root depth to it. A lot of your native species, even looking at some of our grazing species like orchard grass, fescue, some of those kinds of things can be an option in there. A little bit depends on what you're trying to get out of it and what your intended use for it is. So yeah, there are a few that we would recommend, but it really comes back to what are you planning on doing with it?
All right, next question is it common to core the ground to inspect for gravel or sand veins prior to construction?
In some areas, it probably is. I don't know that it is common practice. It's not a bad idea, and especially in areas where there's more of a where gravel and or sand veins are known to exist. I started to say problem, but that's not necessarily a problem. But are known to be an issue if you're thinking about building a pond. And yeah, yes, I have seen that be a little bit of a problem. And that's when we think about over in Missouri in the Ozarks, where you had a lot of that limestone and those creeks over there, a lot of gravel in them. They'd have what they call disappearing creeks, and so essentially you run water running, they disappear, and you show back up somewhere else downstream, further down where the elevation dropped. I've seen ponds built in some areas like that, and the same issue. The pond never filled up beyond a certain point because it essentially was water running under it through a gravel lens. So that can be an issue. Anything else?
All right, we just had a couple more on kind of the wildlife aspect. Someone was just curious about if crawdads or crayfish can cause leaking of a dam, if there are control recommendations.
There is the potential that they could, but I don't. On a larger pond, properly constructed, as far as I know, that shouldn't be a real serious issue. one I need to check into a little bit, but as far as I know, they don't burrow in deep enough to really cause a lot of problems. If everything else is put together correctly.
Okay. With that, we are at just past 2 o'clock, so just in interest of time, I think we're going to stop the questions here. Thank you, everyone, for posting questions in the chat box and for joining us today. Thank you, Jay, again, for a wonderful webinar this afternoon. Please consider taking that evaluation and then joining us next week for our next webinar in our series, which will be about explaining the greenhouse effect. Thank you, everyone, and have a great day.
Thank you.